Okay, so taking us a while to get back into these after having a weekend here. Starting out with this first one, this is just multiplication. I know you see the parentheses, and we've been taught you have to look and make sure you see if there's anything to do there first. But in this case, you look at the parentheses, and is there anything to be done inside those parentheses? No, there's not. So we can't do anything in the parentheses. So our next question is there anything that needs to be done to the parentheses? Well, there really isn't any distributing, but if you look close, you realize what these parentheses are is just multiplication. It's 7x to the third y times 11x squared y squared. So to do that, you multiply the numbers. What's 7 times 11? 77. And then we multiply the names. You take each name or each variable separately. X to the third times x squared is, when we're multiplying variables with exponents, we add the powers. So 3 plus 2 is 5. So x to the fifth. Now there's y times y squared, and the one thing we have to remember is what power is really on this y? 1. So this becomes y to the third, because 1 plus 2 is 3. So 77, x to the fifth, y to the third. Any questions on that one? Okay, then over on number 2, we're dividing. Same process, though. We start out with the numbers. 24 divided by 8 is 3. Then we look at the variables. X to the fifth divided by x to the third, x squared. We're subtracting powers when we divide variables with exponents. 5 minus 3 is 2, so x to the 2. And y to the, 2 minus 3 is -1. For right now, we're going to leave that as y to the -1. In a little bit, we're going to come back and look at that and figure out what can we do to make that look a little bit neater without having a negative power there. Any questions so far on that one? Number 3. This one's a little tricky. We have parentheses again, and again we have to ask ourselves if there's anything that needs to be done in those parentheses. Once again, the answer is no. Second question then, is there anything that needs to be done to the parentheses? That answer is yes. The first set here is 5x to the third times what's in the parentheses. So 5x to the third times 7x to the fourth is x to the seventh. Good. Then it's 5x to the third times a -3x squared, -15, x to the fifth. Good. Now on to the next set of parentheses. Is there anything that needs to be done in that set of parentheses? No, there's not. So then our next question, is there anything that needs to be done to that set of parentheses? Yes. Times what? -4x squared. So -4x squared times 2x to the third is -8x to the fifth. Very good. And then -4x squared times a -5x is +20x to the third. Very good. Now what? All done? We still have to combine. We've got a -15x to the fifth and a -8x to the fifth. So you have the 35x to the seventh, doesn't change. -15 and -8 makes -23x to the fifth. We're adding, so we keep the same name, so we don't combine the powers in this part. And then we still have the 20x to the third. I apologize for the sloppiness there. I ran out of room. Any questions on that one? Anybody get that? A couple of you? Getting close? Okay. Now, LCM. Remember, LCM is least common multiple. If we're looking for the smallest one, that means it's got to be something that's bigger than the numbers. Remember, if we were looking for the biggest one, it would have to be something smaller than the numbers. So multiple is when you multiply it by other numbers and see what it grows up to be. So like multiples of 45 would be 45, 90, 135, 180, and so on. So let's see what we come up with. We could just make those lists like I just said and see what the smallest one is that matches up, or we can factor. If you factor 45, what do you get? Nine times 5, but you can break the 9 down into 3 times 3, right? So you prime factor it to 3 times 3 times 5. From here on out, by the way, when I say factor, what I really mean is prime factor. Break it down into the smallest possible prime numbers. 36 then would break down into 2 times, careful. Remember, when you prime factor, you do the tree. Divisible by 2, so that would be 18. 18 splits into 2 times 9. Those are prime of a circle, and 9 is 3 times 3. So it's 2 times 2 times 3 times 3. Does that look familiar? Bring back some memories? For 36? Because it doesn't work. Yeah, 3 times 3 times 3 would be 27. So you've got a 3 in common. You got a second 3 in common. This one has a 5, so if we put a 5 down there, there's now a 5 in common. This has 2 2s, so we got to put 2 2s up here. So now everything is in common. I'm going to stop. I went through that a little quickly. Did everybody catch what I did there? I just made sure whatever factors were there, I made sure both of them had those factors. If they didn't, I put them in. So now this is 3 times 3 is 9, times 5 is 45, times 2 is 90, times 2 is 180. Here, 2 times 2 is 4, times 3 is 12, times 3 is 36, times 5 is 180. The LCM is 180. Anybody get that? Does that process look familiar? Okay. Let's do another example of just the numbers before I do number 5 up there. To let you guys practice that. We'll call it 4B for right now. So try to find the least common multiple for 20 and 15. So first step, of course, is to prime factor each of those. If I prime factor 20, what do I come up with? 2 times 2 times 5. Any question? Did everybody get that? 2 times 2 times 5. That's the same thing. Just, I always try to put them in order from smallest to largest because it helps me think.
Yeah.
Yep. Now then for 15, that prime factors into 3 times 5. Now the easiest way to start is to figure out what they have in common. What do they have in common? They have 5s. So I'm going to circle the 5s. Anything else in common? No. So now what I'm going to do is I'm going to go to each of them and I'm going to look at what's not circled. And the top one here, what's not circled? The 2. Well, there's 2 2s actually, sorry. The 2s are not circled. So I need 2 2s down here. Now they have the 2s in common. In the bottom one here, what's not circled? The 3s, or the 3. So you put a 3 on top. Now everything is in common. So we know this is 20 times 3 would be 60. This is 15 times 2 is 30 times another 2 is 60. So my least common multiple is 60. Any questions? Is there anybody that thinks they're feeling kind of hopeless on this one? Or don't think they can do this one yet? Okay, so we're holding steady. Now let's go back and try this fifth one here. 12x to the second, y to the fourth. And 18 x to the third, y to the third. I am going to ignore the variables for now and just factor the numbers. 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. Now that I've done that part, I'm going to keep going with the numbers just like I would before. I have twos in a set of 2's in common, and I have 3's in common, right? So I've circled those. This one has an extra 2, so what do I need to do? Put a 2 down here, now they got the 2. What else? This 3 here, I need a 3 up top. Now my numbers are in common, so I'm good with the numbers. Now let's worry about those variables. X squared is x times x. What's y to the fourth? Y times y. Yeah, y, right? What you guys say when you try to do my homework. Now down here, x to the third. I'm sorry, that was me. X to the third, y to the third. What's that got to be? 3 x's and 3 y's. We can handle this now just the same as do with the numbers. We've got an x, another x, a y, another y, and a third y. What's left over on top here? We've got an extra y up here, right? So put that down here. On bottom, got an extra x, and put an extra x up here. So this is 12 times 3 is 36. X to the third and y to the fourth. Down here, this was 18 times 2 is 36. X to the third, that didn't change, and y to the fourth. So 36, x to the third, y to the fourth is our result. You'll notice here there's a shortcut. Once I get that the number is 36, I have variables of x and y. I look up here, I have a power of 2 and a power of 3. Which one ended up in my least common multiple? The bigger one. Same for the y. I have a power of 4 and a power of 3. Which one ended up in my least common multiple? The 4, the bigger one. So if I am trying to find least common multiple, come on. Don't do this. I'll pause here for a second. My computer acts up. So let's say I give you something like 10x to the fifth, y to the third, and 6 x to the third, y to the fourth. I don't have to worry about the variables. We know a shortcut that allows us to just get the variables. Now, if we have to, we can always write them out and, add the ones, put in the ones that are missing if we need to, but we don't have to. If we factor 10, what does 10 factor into if we prime factor it? Just 2 times 5, right? How about 6? 2 times 3. You got it. So what do they have in common? They have the 2's. So up here we have a 5, so we need to put a 5 down here. Down here we have 3, so we need to put a 3 up there. Now we're good. What does that make it for a least common multiple? 30. Very good. What's the variable going to be? So we've got 30 as the number. It'll be x to the 5th, y to the 4th, because that's the largest power on each. For x, we had 5 and 3, so we use the 5. For y, we have 3 and 4, so we use the 4. Always the larger one when it's LCM. So we've got 15 x to the 7th, y to the y, z squared. And we'll have 20 x to the 5th, y to the 3rd. Find the LCM quick. So for the numbers, we're going to factor 15 is 3 times 5. What's 20? 2 times 2 times 2 times 5. Yeah, 10 gets split down into 2 and 5. Now that we have it prime factored, what's in common? Just the 5. So we've got a 3 here, we put a 3 there. We have 2 2's, put 2 2's. So what's that give us for the number? 60. So we have 60. What do we have for variables? X to the 7th. Good, there's an x. We have 4 and 7. 7's the bigger one. What's next? Y to the 3rd. We have y, and so we have 1 and 3, so the bigger one is 3, so y to the 3rd. And then z to the 2nd. We have z to the 2nd here, and there's nothing here, so z to the 2nd is the largest power. Now, not to confuse you, technically this is z to the power of 0. Remember we mentioned anything to the power of 0 is 1. But we just need to know we take the largest power, which will be the z squared. Anybody get that one right? Okay, we're getting closer. Well, now we're going to change gears just a little bit. Reducing fractions. When we were reducing fractions, like 8/12, we were looking for not least common multiples, but greatest common factors. Those were smaller numbers we could divide out. But what we found was we don't need to find a greatest common factor. We just need to find any common factor and start dividing it out. Here, the greatest common factor would be 4. But if we didn't see that, we could divide by 2. That leaves us with 4. 8 divided by 2 is 4. 12 divided by 2 is 6. Then we see that we could divide by 2 again. 4 divided by 2 is 2. 6 divided by 2 is 3. So we get 2/3. What is really happening there, and we mentioned this a little bit last week, is we factored. 8 is 2 times 2 times 2 prime factor. 12 is 2 times 2 times 3. And then we just canceled out the 2's, left with 2 over 3. Canceled out the common factors and saw what's left. Now, let's take that then to our next step. What if we have 10 x to the 3rd over 25 x? What's that? Sure. Now all we have here, if I look at it like this, 2 times 5 times x times x times x, I factored it out. 25 is 5 times 5 times x. So I can cancel out a 5, and I can cancel out an x. So on top, what do I have? I still have my 2. X times x is x squared, and on bottom I have a 5. You'll notice that the variables did not affect how we reduced the numbers. If I just had 10 over 25 and I reduced that, both of those are divisible by 5, would give me 2 over 5. Notice that's the numbers in my answer. So the presence of the variables did not affect how the numbers reduced at all. We just had to put the variables in there before we were done. So we need to figure out how do we work with those variables so that we can combine that then with the numbers when we're done. Well, if we look here, we had x to the third and x. We ended up with x squared. Remember, this is really x to the 1. So what did we do with our powers? We subtracted. 3 minus 1 is 2, so we ended up with x squared. Now, that's not everything we need to know about working with the variables, but that's a start. This next example will show us maybe a little bit more. So here, if I reduce, now notice I'm just pulling the numbers out and working with them without the variables, which always seems to work easiest for me. If I want to reduce the 12 over the 18, what can both of those be divided by? 4 does not go into 18. 3 will go into both. 12 divided by 3 is 4. 18 divided by 3 is 6. Am I done? No, they can both be divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. I now know that the numerical part of my answer is 2 over 3. Now, using what we just learned about our variables, what happens with the x? I have x to the 5th and x to the 3rd. It's going to be subtracting. 5 minus 3 is x squared. Now here's where in our second problem at the beginning of class, we ended up with a negative, right? Here we've got y squared and y to the 4th. If we subtracted, 2 minus 4 would be a negative 2. I don't like negative 2's. But if I look at this, this is y times y. Y to the 4th is 4 of those y's multiplied together. If I'm canceling out, that one cancels, and I'm left with y squared. But where's it at? It's on the bottom. Why did that y, and oh, there's a confusing statement. How come that y ended up on the bottom of the fraction? Well, because the larger power was on the bottom. So when we're looking at the y's, we have a power of 2 and a power of 4. The larger power is on the bottom. So in our result, the y is going to be on bottom. Notice, and that's exactly the right answer, by the way, so it can be positive. If it was on top, it would have been a negative 2, is what we would have had to put on it. So when the larger power is on bottom, the result stays on bottom. The power is still just the difference between them. The difference between 4 and 2 is 2. So let's look at another one. Let's do 8, a to the 5th, b squared, c to the 4th, over 20, a to the 6th, c to the 7th. Where do I start? Start with my numbers. 8 over 20. What can both of those be reduced by? 4. Very good. If I divide by 4, what's 8 divided by 4? An is 2. What is 20 divided by 4? 5. Well, 20 divided by 4 would be 5. 20 divided by 2 would be 10. So now my numerical part is 2 over 5. Now for the variables, I have a to the 5th and a to the 6th. Is it going to go on top or bottom? Bottom, because the larger power is on bottom. What power is going to go on it? Well, 6 minus 5 is 1, so it's a to the 1. Do I need to put the 1 on there? No, so I can write it as just a. Now I have that b squared on top. There's nothing else, so the b squared just stays on top. What about for c? Top or bottom, first of all? Bottom, because the larger power is on bottom. What power? 7 and 4, the difference is 3, so c to the 3rd. So 2b squared over 5a c to the 3rd. So let me try one. Try that one in your notes. So the 4 over 8, what can that be reduced by? Both can be divided by 2. Those will give you 2 over 4, and they can still be divided by 2, give you 1 over 2. So up here, our numbers are 1 over 2. Now notice I didn't write the 1 on top because I might not need it. I'll show you why. So for the x's, where's the x going to go? Top or bottom? It is going to go on bottom, and it'll have a power of 1. So we don't need to put it there, right? So just x. Y is going to go top, power of 2. The difference between 5 and 3 is 2. Now I could have put the 1 up here, but at this point I would have to probably take it away because I don't need that 1 in front of the y squared. If you had the 1 there, it would not be wrong. It's just same as just writing x. You don't usually write 1x, you just write x or whatever. Now you would have to have it there if there was nothing else up there. You'd have to have the 1 there so that there's something in the numerator. Now there is some differences between these algebraic fractions and our regular numerical fractions. One of them is this. I've got 9 over 6. I got to reduce that. First of all, we do see that both of them can be divided by 3, which gives us 3 over 2. Now, our tendency would be to want to change 3 over 2 into 1 1/2, wouldn't it? Guess what? Don't do that. When you have the variables up there, you cannot change it into a mixed number. The only time you can change it into a mixed number is when the numerator is bigger than the denominator. The number, however, does not stand alone here. It has the variables, the x and the y. We don't know what values x and y have. They do have values, we just don't know what they are. This numerator really could be smaller than the denominator, even though the number part is bigger. So we really don't know if this truly is an improper fraction. So unless we're sure, we cannot make it into a mixed number. So we must leave that as 3 over 2. It cannot become a mixed number. I will catch at least a couple of you on the test trying to do that. So be careful with it. Now what happens to our x? It goes on bottom. X squared, good. The bigger power was on bottom, and the difference between 5 and 7 is 2, so it's x to the 2nd. How about y? Y goes on top, because the bigger power was on top. You know, the Difference between 3 and 1 is 2. So y squared. So 3y squared over 2x squared. What do you think? Still better than a sharp stick in the eye? Maybe? Okay. Let's have you guys try one. Try that one in your notes. So for the numbers, we've got 35 over 20. What can both of those be divided by? 5. Very good. So divide by 5. 35 divided by 5 is 7. 20 divided by 5 is 4. Does that become 1 3/4? Say no. No. Stays 7 over 4 because of the variables. Now what? A goes where? On the bottom. Bigger power was on bottom. And what power? 1. So just A. Good. What's next? B goes on top to the power of 3. 5 and 2 makes 3. What's next? C goes where? Top. What power? 3. There was no other C's to deal with. And then D on bottom, and it's D squared because there's no other D's to deal with. Any questions? How many of you had that one completely right? Good deal. We're getting closer. What's that mean? Yeah, 2/3 to the power of 4. The whole fraction is to the 4th power. It means 2/3 times 2/3 times 2/3 times 2/3. 4 of them multiplied together. But when we multiply fractions, we simply combine the numerators. That would be 2 times 2 times 2 times 2, which is 16. And we combine the denominators. 3 times 3 times 3 times 3 would be 81. So realistically, when we take a fraction to a power, now by the way, your fraction calculators will do this. You can put the fraction, if you put it in parentheses and raise it to a power, it will do that. But you have to put the fraction in parentheses just like I did here. Do parentheses 2, then hit the ABC key, 3, close parentheses, then to the power of 4. On yours, you probably have an X to the Y key, where the power looks something like that instead of the caret key. And it gives you the 16 over 81. But realistically, when you see this 2/3 to the power of 4, you can just split it up to this. 2 to the 4th over 3 to the 4th. So if you don't remember how to do the fraction in your calculator, 2 to the power of 4 is 16. 3 to the power of 4 is 81. So we might have 5x squared y to the 5th power of 3. Oops, sorry. Let's do this right. Over 2 x to the 3rd y. Actually, let's make it easy, sorry. Let's put this as z's down here instead of y's. Over 2 z to the 3rd. Like that. I'll throw that other part in the next step. We'll go slow. So here, what's happening is this fraction is just being taken to that power. So to do that, it's going to be the top, 5x squared y to the fifth to the power of 3, and the bottom, 2z to the third to the power of 3. I'm going to stop there. Does everybody see what I did there? I just separated the fraction. I have that fraction to the power of 3, so I just separated it so the top, the numerator, was to the power of 3, and the bottom, or denominator, was to the power of 3. And now do you remember how to take something to a power? You do the number to the power, the count to the power. What is 5 to the power of 3? That's 5 times 5 times 5, or 125. Next, you have to do the variable x squared to the power of 3. What do we do with our powers when we raise a power to another power? You add the powers. Very good. Oh, no, you don't add the powers, sorry. You multiply the powers. So x squared to the power of 3 is actually x to the 6. Remember, x squared to the power of 3 is x squared times x squared times x squared. 2, 2, and 2 make 6. So what's next? We have y to the... Anybody want to venture? 15th. Perfect. Over 2 to the power of 3. Careful, that's 2 times 2 times 2, which is 8. Z to the 9th. Now you can see the confusing part here is the variables, the powers, are multiplied. The numbers, though, are still to their power. So the natural confusion, the natural mistake is 2 to the third, well, that's just 6. 2 times 3 is 6. No, the number is still taken to the power. 2 to the third is still 2 times 2 times 2. Z to the third is still z to the third times z to the third times z to the third. The difference is when you multiply, you'd add the powers, and when you're adding over and over again, that's multiplying. You are multiplying. 3 times 3 is 9 on the power. So let's have you try one. Try that one there. 3x to the fifth over 2y squared, all to the third power. So we're going to separate this in 3x to the fifth to the power of 3 and 2y squared to the power of 3. So 3x to the fifth to the power of 3, we're going to do 3 to the power of 3, which is 3 times 3 times 3 is, careful, 27. There you go. X to the power of, now it's, when you have a variable, remember x to the fifth to the third is x to the fifth times x to the fifth times x to the fifth. That's a total of 15 x's multiplied together. So on the variable, the power is multiplied by the other power. The number still is raised to the power. So this is 3 to the fifth, which is 3 times 3 times 3, or 27. X to the fifth to the power of 3. I gotta put 5. That's 3 to the third, I should say. That is still 3 to the third, which is 3 times 3 times 3, or 27. This is x to the fifth to the third, which is x to the fifth times x to the fifth times x to the fifth, which is x, 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 and x, 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 or 15 x's multiplied together. So the appearance is that these powers get multiplied. When you're combining two powers, just like when you're multiplying, you add, and you divide, you subtract. Well, when you're taking a power to another power, you multiply. So So those powers behave a little bit differently. So next, down on bottom here, 2y squared to the power of 3. 2 to the power of 3 is, be brave, the worst that could happen is you're wrong, we won't laugh. 8, very good, 2 times 2 times 2. Now y squared to the power of 3 is y to the 6, very good, 2 times 3 is 6. Let's try another one. Now remember, variables with powers. When you are multiplying, you add the powers. When you are dividing, you subtract the powers. When you're taking a power of a power, you multiply the powers. When you are adding or subtracting, you first of all must start with the same power exactly, and 2, you just keep the power. What do I mean by that? Let's recap. So if I had 13 x to the 8 plus 8 x to the 8, can I add those? Yes, because they have the same variable and the same power. The key rule for adding, that will always be the key rule for adding, no matter what, is to add or subtract, you must have the same name. Period. Next. So that's we're going to combine the counts. 13 and 8 we're adding, so that becomes 21. X to the 8, we keep the same power. So that's adding or subtracting. If I were multiplying, 5x to the 3rd times 2x to the 7th. I do not need the same name to multiply or divide. So when I multiply, I combine the counts. 5 times 2 is 10. And then I also combine the names. X to the 3rd times x to the 7th is x to the 10th. When I'm multiplying names, I add the powers. If I am dividing, again, do I need the same name? No. I'm just going to divide the counts. 12 divided by 4 is 3. And then I'm also going to divide the names. X to the 5th divided by x to the 3rd. When I am dividing, I subtract the powers. 5 minus 3 is 2. So that's kind of a review of our last couple of classes. Now, when we had a power, like 3x to the 7th to the 4th, this is what our last step that we just did. The number still goes to the power. What is 3 to the 4th power? Well, that's 3 times 3 times 3 times 3, right? Which is 81. Yeah, 27 will be 3 to the third. There's 4 of them. So 81. But for the variable now, when you take a power of a power, the powers are multiplied. 7 times 4 is 28. Questions? So let's take 5x to the third y over 3z to the fifth, all to the power of 4. Remember, when we're taking the power of a fraction, we split it up. So the power goes on the numerator. So 5x to the third y gets taken to the power of 4. And on the denominator, so 3z to the fifth will also be to the power of 4. So this is going to be just like what we just did. 5 to the power of 4 is 5 times 5 times 5 times 5, otherwise known as 625. Now I'm going to pause. I'm going to give you guys a chance to put that in your calculator. Make sure you can come up with the 625. Make sure you guys are entering the powers in correctly. You guys all good with that? Okay. Now what happens to the x? Yes, it's a power of a power, so 3 times 4 is 12. X to the 12. How about our y here? Well, this is y to the 1, so yeah, 1 times 4 is 4. That is y to the 4th. Any questions so far? Okay, now we go to the bottom. 3 to the 4th power is 3 times 3 times 3 times 3, which we just saw up above is 81. 81. And z to the 20th. Very good. 5 times 4 is 20. And that is it right there. Because this is y, there's no power there, so it's y to the 1. So it's just 1 times 4. So let's have you guys try one. So 2x to the 5th over 5y z to the 3rd. All to the 3rd power. Okay, so we separate it. So we take the power to the numerator, so it'll be 2x to the fifth to the power of 3, which is going to be 8x to the 15. Very good. How many of you got 8x to the 15 on top? A good share of you. Most good. On bottom, then, it's going to be the 5y z to the third, all to the power of 3. So it's going to be, what's the number? 125, 5 to the third power. And then y to the third, this is y to the 1, so 1 times 3 is 3. And z to the 9. Perfect. How many of you had that all right? Good. Okay. Well, it is time for our break, so let's go ahead and take our break. We'll come back. It's 10:13. Let's try to come back at 10:23.